All right, so for worksheet 13, I wanted to do a couple of them together just to point out a couple main ideas and details and stuff that you should be aware of. So let's start with number 1. Just looking at as far as like the theorems go, this should be pretty straightforward. These are two tangents, and when two tangents come from the same exterior point, those two tangents are congruent. So tangent is going to equal the other tangent. So we can say 2x squared plus 12 is equal to 11x minus 3. What you might see here in order to solve is that we're going to have to solve a quadratic. So this one's a little bit tricky. That's why I wanted to go over it with you guys. First thing we need to do is set the quadratic equal to 0. So we're going to move all of these guys over to the same side. So I'm going to subtract the 11x. I'm going to add the 3, which gets us 12 plus 3 is 15 equals 0. So now we have to factor. So the two first terms have to equal 2x squared. So that's going to be a 2x and an x. And then they have to, we have to pick two numbers that multiply to 15 and add to the negative 11x, but we have to take that 2 into consideration as well. It gets a little trickier. What you guys see on your test will not be this tricky with the leading coefficient of 2. But you can do guess and check or whatever method you learned how to solve quadratics. We get -5 and -3 are the numbers we have to fill in there. So here we have our two factors, 2x minus 5 and x minus 3. After we set the equation equal to 0, after we factor, then we have to take each of these individual factors and set those equal to 0. So 2x minus 5 equal to 0 and x minus 3 equal to 0. Now we just solve. We're going to add the 5, divide by 2. Here we'll just add the 3, and we have our two values for what x could equal. Now in this case, when we plug those values back into the original expressions, we get appropriate segment lengths for both of them, so x can equal both of those values. Okay, let's take a look at number 3. This one's tricky just because we have concentric circles here and there's a lot going on. Just take it step by step, you guys. So start with what you're given. The measure of angle RGI is 27. So find that angle, RGI. This angle right in here is 27 degrees. Now this angle has its vertex on that large circle. So that's an inscribed angle. That means whatever arc it eats will be double the amount of that angle. So if that angle is 27 degrees, the measure of this arc is double it at 54 degrees. Okay. Let's just stick with the arcs for right now. Let's see, are these angles and arc measures? Let's see what else they want us to find. They want us to find the measure of angle RSI. So RSI is a central angle. And if you see in the central angle, it eats this arc, which is 54 degrees, and central angles are the same measure as their arc. So this angle is 54 degrees as well. Okay, so again, piece by piece, step by step. The rest of them, they want the measures of the arc. So let's look, they want the measure of arc RI. So we already figured that one out is 54. How about the measure of arc RGI? So arc RGI is the rest of that circle. If this arc is 54, the rest of the circle around has to be, they have to add to 360, right? So if we have the total and we subtract 54, we'll be left with the remainder of 306 degrees for that arc. How about the measure of arc PN? So PN is on this inner circle. So PN from here to here is on the inner circle, but do you guys see it still has that same central angle measure? So it should have the same rotation from P to N. We've rotated the same amount, is 54 degrees. So the measure of arcs, remember, is how far you're rotating around. But the last two, they want not the measure of the arc, but the length of the arc. So actually how many feet, inches, miles it would take to go from R to I or from P to N. So visually we see that arc RI is going to be longer than PN because it's a wider arc, right? The radius from each arc is different. The radius from the center to R is different from the radius from S to P, right? In fact, that's some missing information we should fill out here. Looking at the given information here, it says segment SR is 8. So SR, the long radius, is 8. So the radius of the large circle is 8. Then SN, the radius of the smaller circle, SN, is 6. So we need to use that information when we're finding the arc length. So remember, arc length is a fraction of the whole circumference. So if they want the length, the arc length of arc PN, it's going to be that fraction. So 54 over 360, that's the fraction of the whole circumference of the small circle. So we use the small circle's radius. Multiply through, you get 9 pi over 5. Okay, versus RI, they want the length, not the measure of that arc. The fraction of the circle is the same, 54 out of 360, but the circumference of the big circle is different because it has a different radius. So we're going to use that 8 for the large circle, multiply through, and we get 12 pi over 5. Now that makes sense because in the beginning, remember, we said the length of RI should be larger than the length of PN because it's in the larger circle, so it all works out. Okay? All right, let's keep going. Number 5, this one uses the theorem that says that if an inscribed angle intercepts a diameter or intercepts a semicircle, which is what's going on here. They told us that AB is a diameter. AB is a diameter. That means this arc is a semicircle, and semicircles have a measure of 180 degrees. So the inscribed angle that eats that arc should be half of the arc measure. So half of 180 is 90. And so that's a theorem that says that if there's an inscribed angle that intercepts a semicircle, then it's going to be a right angle. So we do have a right angle there. Now that we know all of that, we go and look at the rest of the information. They're telling us that the measure of angle A is 1/2 x. The measure of angle B is 1/3 x plus 5. These two angles, if we were to think of this as a right triangle, if this is a right triangle, all three angles have to add to 180, right? Or just looking at these two acute angles, these have to add to 90. They're complementary. So knowing that information back from our triangles chapter, we can say that angle A plus angle B has to add together to equal 90. So we're going to have 1/2 x plus 1/3 x plus 5 has to equal 90. So here we just have to use our calculator, deal with some fractions for a little bit. You can find common denominators if you wanted to do it by hand, but honestly, just use your calculator. Here we're going to get 5/6 equals 85. To solve, we're going to multiply both sides by the reciprocal. So multiply both sides by 6/5. So then the 6's cancel, the 5's cancel, so we're just left with 1x. 85 times 6/5 gives us 102. So x equals 102. Okay. And then just two more that I wanted to look at were numbers 11 and 13. So looking at the diagrams here, very similar diagrams, right? We have two chords intersecting and angles within the circle. So you have to be really careful about what formulas you use and what they want you to focus on. Number 11 gives us all arc and angle measures. So you want to make sure you use the formula that says if the vertex of the angle is inside the circle, it's going to be at the average of the two arcs. So arc plus arc. Now we just plug in the values they give us in the right spots. The angle measure is 100. One of the arcs is 135. The other arc is x. So x happens to be inside of the formula that we're solving. So we're going to multiply both sides by 2 because 1/2 times 2 is just 1. So that cancels, and what's inside of the parentheses comes out untouched. 2 times 100 is 200, and we can solve for x is 65 degrees. X is an arc. Okay, so number 11 had to do with all the angles and the arcs versus number 13, same diagram, but this time we're looking at the segment length. So here's chord. With chord, we're going to take the two parts of each chord and multiply them together and set them equal to each other. So here it's going to be 2x times 3x is equal to the product of the other two parts, 3 times 18. So we can go ahead and solve. 2 times 3 is 6. X times x is x squared. Don't forget that x squared part. It's kind of a big part of this equation to solve. So here, we're just going to start isolating x. Divide both sides by 6. We get x squared is 9. Here we can take the square root of both sides. X equals plus or minus 3. Don't forget the plus or minus because x can be both. Before we put a box around our answer, we have to make sure that the values we give as our final answer work with the geometry problem. If we plug in positive 3 into the x's, we get appropriate values. So x can be positive 3. Can x be negative 3? If we plug in negative 3 and for x, 3 times negative 3 is negative 9. Can a segment length be negative? No. So that's why we're only going to leave a final answer of x equals positive 3 because that's the only x value that gives us an appropriate segment length. Okay? Awesome. So try the rest of worksheet 3 out. There's a lot of really good questions, and let us know if you have any questions. All right. Happy studying.